We talked about polynomials and how they are terms with many, well, expressions with many terms. This is a model of a polynomial. This polynomial is 2x squared plus x minus 2x plus 4 minus 1. What they've done is they've laid down all the tiles that match this. When I ask you to simplify, what I'm asking you to do is to combine and distribute. So distribute obviously first if you have an option, which we don't here, and combine all of your terms until you have nothing, you only have one, you only have one of each type of thing left. So when I say that, what I mean is, if I look at this, when I have a model, what I'm going to do is I'm going to cancel out every zero pair that I can. So in this case, if I look here, I have an x and a negative x, and when I put x and negative x together, they make zero. So like if I have $1 and I spend $1, I don't have any dollars anymore. I've got no dollars. So we're going to cancel out those zero pairs. So I have this x and this negative x. I don't have any more x's to cancel this negative x out with. I didn't have any negatives to cancel out these x squareds with. Over here, though, I have these 4 1s, and I have this 1 negative 1, so I can cancel that out. That leaves me with 2 x squareds, 1 negative x, and 3 positives. So that looks like 2x squared minus x plus 3. If I look at this next problem, same thing. I'm going to go through, I'm going to look for zero pairs that I can cancel out. So here I have 2 positive x squareds and 1 negative. So one of these pairs can cancel away. I have 2 negative x's and 1 positive x, so 2 of those can cancel away. I have 1, 2, 3 positive 1s and 2 negative 1s, so I can have 2 of those cancel away. What's left is 1x squared, 1 negative x, and 1 positive 1, which looks like x squared minus x plus 1. Okay, and then as a final example, this last one here, I can cancel out these 2 x squareds. I don't have anything to cancel these negative x's with, and I can cancel out one of these pairs of positives, which leaves me with negative x squared minus 2x minus 1. So that's how we model combining polynomials. Now, that was modeling. Now we're going to actually look at doing it algebraically. Okay, so the first problem we have here is addition. Now we see these a lot, and a lot of times folks tend to get confused because they have this stuff in parentheses and a plus sign and more stuff in parentheses. So they think they're supposed to do something with it. But what you always think about is you look at what's in front of the parentheses. If I distribute nothing to the stuff in front of the parentheses, is it going to change what's inside? No. So if it doesn't, I can just bring it down without even changing anything. I don't have to mess with anything at all. Same thing here. If I multiply everything by positive 1, does that change what's inside the parentheses? No, it does not. So I can just add exactly what I see inside the parentheses. Now that I've gotten rid of the parentheses, because the first step is to do any distribution that I'm supposed to do, then I'm going to look at combining my terms. Now, as I've told you guys before, the way that I separate out my terms is I put walls between them so that I can more easily tell them apart. This is visually kind of confusing to me. So what I do is before each plus or minus sign, I put up a wall. And you don't have to do one in the front, but you can if you want to. And then what I do is I look for the things that are the same. Now, we talked yesterday about how with polynomials, we always put them in order from the highest order exponent first, which means we're going to look for the highest exponent. And the biggest one I see is the squared. So I'm going to combine these two. And when I combine them, so when I'm adding or subtracting, I don't mess with the exponents. I've seen a lot of people asking, well, should I put should it be, 4x to the 4th? No, because I don't mess with the exponents unless I'm multiplying and dividing, which we haven't gotten to yet. When I'm adding or subtracting, all I do is combine the coefficients. So negative 3 plus 7 means I've got 4 x squareds. Okay, now I'm going to look for the next highest exponent. Well, I've got the invisible 1 here for my linear terms. I've dealt with my quadratic term. Now let's look at my linear term. I have a 5x and a negative 4x. Well, 5 minus 4 is positive x or positive 1x. You can put the 1 there if you want to. We don't, but it's not wrong if you do. Okay? And then the last thing we're going to look at is our constant term. I have negative 9 minus 1, which is minus 10. I know that I'm done simplifying when I only have one of each type of term. I have one quadratic term, one linear term, and one constant term, so I know that I'm done, and this is my final answer. Okay, let's try another one. This one here, I have 6x plus 4 plus 5x squared plus 4x. Okay, so first thing I'm going to do is I'm going to look at these parentheses. They gave me parentheses. I want to make sure I don't have to distribute anything. Well, there's nothing in front of this, so the 6x plus 4 can come straight down. And there's a plus in front of the 5x squared plus 4x, which means nothing inside is going to change. So I'm going to bring plus 5x squared plus 4x. Now, I'm going to put up my walls to separate my terms. And then I'm going to look for the highest exponent, and that's what I'm going to start with. Well, the biggest exponent I see is 5x squared, and I only see one of them, so that comes straight down, and I'm done with that one. The next biggest exponent I see is my invisible 1, my linear terms. 4x plus 6x is 10x. And then the last thing I see is this positive 4, and it's my only constant term, so it's all I've got. And then I check, have I simplified completely? I only have one quadratic, one linear, one constant term, so I know that I finished simplifying this answer. Now that's addition. It gets a little trickier when we do subtraction. And the reason why it gets a little trickier with subtraction is because with subtraction, when I'm subtracting, this does change things. So if I look at this first thing, so again, my first step is to deal with parentheses, okay? So here I've got 6x plus 4, and there's nothing in front of it. So that means this 6x plus 4 can come straight down. Now, when I look at this negative out here, what negative means is opposite. So that means 6x4 and the opposite of everything inside these parentheses. So that means everything in here I have to take the opposite of. So it was positive 5x squared, now it's negative 5x squared. It was positive 4x, now it's negative 4x. It was positive 1, now it's negative 1. So I have to switch the signs on everything inside. So I have to make sure that I take the opposite of each of the things inside of it. It's almost like I'm distributing the negative to everything inside, which is kind of what I'm doing. Now that I've done that distribution step, now I can start to combine my terms. So I put up my walls, and I find the highest exponent, which is negative 5x squared, my quadratic term. It's the only one, so I bring it straight down. Now look for the next one, which is my linear term. I have two of them. 6 minus 4 is positive 2x's, so that's my linear terms. And now I have my ones. 4 minus 1 is positive 3. I have one quadratic, one linear, one constant, so I'm done. Okay. This next one has a lot going on. Okay, so first of all, when I look here, I do have something in front of my parentheses. So I have to distribute that. Means everything inside has to be multiplied by 2. I have to take twice everything inside. So 2 times x squared is 2x squared. 2 times x is positive 2x. 2 times 3 is positive 6. So now I finished this part. Now, I have to look at this. Minus all this stuff, that means I'm going to take the opposite of x squared, which is negative x squared. I'm going to take the opposite of negative x, which is positive x. I'm going to take the opposite of negative 1, which is positive 1. Now that I've done that, I can put up my walls. Now, I haven't done this before. I didn't have a problem to do it on, but now that we look at this, if you look, these x squareds and x's, they don't confuse me, but they're easy to make mistakes on, especially when I'm thinking about combining the exponents. So when I'm doing this step, I'm going to put a 1 in front of anything that doesn't have a 1 in front of it. So this negative x squared became negative 1x squared. Let's make that 1 look less like a wall. There we go. And this 1x became, the positive x became positive 1x. Now when I start combining my like terms, I'm not going to forget that there's one of those. So I'm going to look at my highest exponent. I have negative 1x squared and positive 2x squared. 2 minus 1 is x squared. 1x squared, again, or just x squared. Now I look at my linear terms. I have 2x plus 1x, that's positive 3x. And I look at my constant term, and I have 6 plus 1, which is positive 7. I have one quadratic, one linear, one constant, so that's my final answer. Now, one of the last things that you may be asked about is you may be asked, to find perimeter of rectangles. Now we will also do area in the next video because we're going to talk about how to do area, how to multiply. But if you're asked to find perimeter, the thing that's going to trip you up, you've got to be careful of, is remember, this does not just have two sides. It's got four. It's got x squared plus 1 here and x minus 1 there. And it is really easy to make that mistake. And they will have an answer choice where they only add up the two sides. Now, there's a couple of ways you can do this. You can do this the traditional way where we do, x squared plus 1 plus x squared plus 1 plus x minus 1 plus x minus 1 because, we're finding the perimeter, which means add all the sides. Or if you want to well, let's just do it that way. It's easiest that way, okay? We put up our walls. Okay, and then I'm going to put ones in front of all these. Ooh, boy, there's a lot going on there. I'm going to start by looking at my quadratics. That means I've got 2 x squareds. Now I'm going to look at my linear terms. I've got 2 x's. 1 plus 1 is 2, minus 1 is 1, minus 1 is 0. So this is all that's left, 2x squared plus 2x, because the constant terms cancel each other out. This is pretty much the kind of questions you'll be asked about adding and subtracting polynomials. Again, the biggest thing to be careful of is, number one, making sure that you correctly separate your terms, and then making sure that you are very careful about distributing the negative and about combining your integers and not making arithmetic mistakes. If you do all those things and are careful, you should have no trouble with adding and subtracting polynomials.